So now that we've talked about the definition of a function being continuous at a point, the question is, how do you know if something is continuous? So what are the type of discontinuities that we could have? So let's go over the different discontinuities. So there are three types of discontinuities, and I'm going to show them to you. Coincidentally, these are where one of the three things fails in the three things you need to be continuous. So the first one is I'm going to draw the picture of f of x. It's going to be defined piecewise, so it'll be x for x not equal to 0 and 1 for x equals 0. So what does this function look like? Here's my x-axis, here's my y-axis. It says that for everywhere except at 0, my function value is the line y equals x. So everywhere except for 0, there's my function value. But when x is equal to 0, my function is equal to 1. So that's the picture. And I want to know, is this continuous at x equals 1? Now your intuition says, no, it's not, because I can't draw this line without picking up my pencil, but the question is why. So let's go through those three things. First of all, is f of 0 defined? Is there a function value? Well, the function says when x is 0, my function value is 1. So that one does not fail. Number 2, what's the left-handed limit for 0? So as I approach 0 from the left, what are my function values doing? They're going towards 0. And what's the right-handed limit? Well, let's see. As I approach 0 from the right, you can see my y values are going towards 0. So number 2 was satisfied because my left-hand and my right-hand limits were the same. But now let's look at number 3. In part B, we found that the limit as f approaches 0 of f of x is 0. So remember, whenever the right-hand and left-hand sides were equal, that was your limit. The question is that equal to f of 0? Well, f of 0 was 1. We found that in part 1. Since these two are not the same, then we say this is not satisfied. So that's the first type of discontinuity. Whenever you have that the limit exists, but the limit is not equal to your function value, that's called a removable discontinuity. So removable discontinuity. And that's the first type of discontinuity. So whenever I have something like this, where it's kind of 1 point off by itself, that's going to be a removable discontinuity because the limit exists and the function is defined, but the limit does not equal the function value. So that's your first type of discontinuity. So that's where number 3 fails. Let's go to our next one. Next example that we're going to look at is I'm going to let f of x, again, be defined piecewise. Let's let it be x for x less than or equal to 0, and then 3 for x greater than 0. So what does the graph look like here? Here's my x, here's my y. This says for all x values where x is less than or equal to 0, my function is just given by x, which is a line. So there's that part of the piecewise function. Then it says for all values greater than 0, my function is just the horizontal line 3. So there's 3. I want an open circle there, and there's the rest of my graph. I want to know, is f of x continuous at x equals 0? So remember, to be continuous, I have to satisfy 3 different things. We need to have that f of 0 is defined, the limit exists, and that limit was f of 0. So let's go through and figure out which one of these fails. I mean, you can tell it's going to fail. The question is which one. First of all, can I plug in 0 into my function? Well, let's see. 0 is less than or equal to 0, so I plug it into my first piece, so I get 0. So number 1 is satisfied. We'll come back to number 2. Actually, we'll just go ahead and do number 3. Alright, number 2, and then we'll do number 3. Let's look at the left-handed limit. So As I go from the left and I'm approaching 0, what are my y values doing? You can see they're getting closer and closer to 0. Now let's look at the right-handed limit. As I approach 0 from the right, what are my y values doing? They're getting closer and closer to 3. These two are not equal, so number 2 fails. So we would say that the limit does not exist, and that also makes number 3 fail. So the limit, as x approaches 0 of f of x, does not exist, so it definitely does not equal 0. So this example is called a jump continuity. Sorry, jump discontinuity. So we had the removable discontinuity in part 1. That was where I had one piece or one little point kind of off to itself. Here's a jump continuity because I kind of jump from a function to another function. So whenever number 2 fails, that's called a jump discontinuity. And then when number 2 fails, definitely number 3 is going to fail. So that's your second type, is a jump discontinuity. We have one more type of discontinuity, and for that, I'm going to look at the function f of x is 1 over x squared. Now this function kind of looks like this. Here's my x, here's my y, and I want to know, is this continuous at 0? So all of these examples, I've been looking at x equals 0. You could look at any other x value, but we're just going to talk about at x equals 0. So to be continuous, again, we need 3 things. Number 1, what is f of 0? Well, f of 0, I can't plug that in, so this doesn't make any sense. F of 0 does not exist, so automatically this is not continuous at 0. But let's just check to see if the other two hold. So number 2, what's the limit as x approaches 0 from the left? And then what's the limit as x approaches 0 from the right? Well, let's see, from the left, as I approach 0, my function goes off to infinity. As I approach 0 from the right, my y values grow and grow, so off to infinity, which tells us that the limit as x approaches 0 of my function is infinity. So even though the limit exists, the function is not continuous because there was no function value. So in this example, the limit exists, the limit was infinity, but f of 0 does not exist. So it's discontinuous. This is not continuous at x equals 0. What is this called? This is called an infinite discontinuity. Infinite discontinuity. So that's your third type of discontinuity. And you can, it's kind of clear, I think, why it's called an infinite discontinuity, because I'm going off in the infinity direction. Now, I could be going off in the negative infinity direction. That's the same idea. This is an infinite discontinuity. So, those are your 3 types of discontinuities. You can see that there's one type for every one of the 3 things that fails in the definition of continuous.